Hello my dear students, I warmly welcome you to SIA's digital classes. In this lecture, we are going to discuss about elementary properties of a group. This one is the second elementary properties of the group. So now see what is the second elementary property of the group. So we are going to discussing in the form of theorem. So that is, see the statement of the theorem, state and prove the cancellation laws. Or else in the examination, they also ask in this format, let A comma B comma C belongs to capital G and star be the binary operation on capital G. Then prove that left cancellation law, prove that the right cancellation law. Okay, these two are the cancellation laws. In the examination, state means you have to write down the statement of this theorem only. This is the definition of the cancellation laws. State, that means that this total statement of the theorem. Prove means we are going to proving now. Okay, so now see the proof. Given small a comma b comma c are three elements in the group capital G. Okay, star be the binary operation. Star be the binary operation. So here binary operation I am taking as multiplication, because in the left cancellation law, right cancellation law, we are using multiplication only. So therefore now first property is left cancellation law. Left cancellation law. Left cancellation law. Left cancellation law. So claim, we have to prove that A into B is equal to A into C, which implies that B is equal to C. This is the claim we have to prove. Okay, so now suppose A dash is the inverse of small a. Inverse of small a. A dash is the inverse of small a. Pre-multiply with A dash on both sides. On both sides of AB is equal to AC. So now if you multiply, so then A dash into A into B is equal to A dash into A into C. Okay, now this property, okay, so is associative. Now we can write A dash into A B is equal to A dash into A into C. According to the associative property, that equation we can write as A dash into A into B is equal to A dash into A into C. Now here A inverse A dash is the inverse of A. That means their multiplication is equal to identity element. Okay, so here clearly you can know that A dash into A is equal to small e. A dash into A is equal to small e. Now by identity property, we can write A dash into A is equal to small e. Small e into B is equal to, in the RHS also, small e into C. So if you multiply any number with identity, again you will get the same number only. So therefore B is equal to C. This is the required condition we have to prove in the LCL, left cancellation law. So therefore B is equal to C. So now we are going to prove that right cancellation law. Right cancellation law. Claim. So B into A is equal to CA, which implies B is equal to C. This is the claim. Now suppose here also same process. A inverse is the A dash is the inverse of A. That is, clearly you can write A dash into A is equal to small e. Post multiply with post multiply with a dash on both sides of BA is equal to CA. Then you will get that BA into A dash is equal to CA into A dash. Now by using associative property, you can write B into A dash separately, C into A dash separately. By using identity, here associative, okay. Why? Because capital G itself a group. They are clearly mentioning in the statement capital G is a group. That means closure associative identity inverse properties will exist. So associative property. Now by using inverse property, okay, so you can write that value small e, C into small e. So therefore, if you do the process, B is equal to, by using the left cancellation law, we prove the same condition, B is equal to C. By using the right cancellation law, we prove the same, B equal to C. So therefore, hence, in a group G, cancellation laws hold. Okay, hence, in a group G, cancellation laws hold. Cancellation laws hold. Okay, while solving the problems and theorems of the algebra, these cancellation laws plays key role in algebra. Okay, so whenever we are going to prove a theorem, instead of doing the cancellation property, if you just state the by left cancellation law, if you just state the by right cancellation law, you will get the next step without cancelling the elements. Okay, with respect to multiplication, with respect to addition, whatever it may be. Okay, so this is the about the second elementary property of the group, that is cancellation laws are hold. Okay, I hope you understood this theorem very well. In the next lecture, we are going to discussing about the third elementary properties of the group. Thank you.